at a word problem that uses variation functions. The manager of a company assembly plant knows that the number of computers that the workers can assemble varies directly as the time. If the workers can assemble 1,260 computers in 150 hours, how long will it take them to assemble 1,890 computers? A couple things to make note of. Be sure to define your variables. So in our case here, we have x and y. And because we see that it varies directly, which means we are using y equals k times x. And I see computers and hours. The other thing I want you to remember from Algebra 1, time is always x because time is always independent. So I'm going to put down for my x that this is time in hours and that y is going to be the computers assembled. So then our process is simply going to be the same as it has been before. So step one is to set up that variation equation. So I see here that I've got y being equal to 1,260 when x equals 150. Now we're back to where we were before. So y, 1,260, is equal to k times 150. So we will go ahead and divide by 150 on both sides. And when we do that, 1,260 divided by 150 gives you 8.4. So k is equal to 8.4. Then we can, once we've solved for k, we're going to rewrite that equation with k. So we have that y is equal to 8.4x. And now I see how long to assemble 1,890 computers, which is y. So we'll put that into our equation. We've got 1,890 is equal to 8.4 times x. Divide both sides by 8.4. And when we do that, we get 225 hours. All right, there's one step that I forgot you to add in there once we got that 225 hours, and that is step 4, where we answer the question using the equation with k in it, which is exactly what we did, where we answered the question to get x equals 225 hours to assemble 1,890 computers. This last piece is taking a look at how we tell if a set of ordered pairs is a direct or indirect variation. When we look here at direct variation of our y equals kx, this means if we solve for k like we've been doing, we get y over x, which should look familiar because this is a constant ratio. This is like your slope of your line, which is why when you see y equals k times x, in the past you've known this as m. On the other hand, when you have an inverse variation of y equals k divided by x, when you solve for k, you get x times y, which is going to be a constant product. So when we take a look at a problem like problem E, where we have this table of x and y values, the first thing we want to do is check to see if there's a constant ratio between y and x. So if we take a look at y over x, for this first one, we have 8 over 6.5, then we have 4 over 13, and then we have 0.5 over 104. One of the things I notice is that in this first one, 8 is bigger than 6.5, but in the others, the numerator is smaller than the denominator. So that I know, therefore, that there's no constant ratio, so it's not a direct variation. Once we know that, we can go ahead and try step 2. And if it's not a constant ratio, we can check to see if there's a constant product between x and y. So the next thing I want to do is I want to take a look at x, y. So when I take 8 times 6.5, that I get 52. And then if I take 4 times 13, I get 52. Now I know a lot of you want to stop right there, but you should check all of them because I'm known for throwing a loop in for you at the end. If I take 0.5 times 104, half of 104 does in fact give me 52. And it says here, if so, it's an inverse variation. So we would write down here that this one has an inverse relationship. Now, some of you might be wondering what step 3 states. Step 3 simply says if it's not a constant ratio or product, then it's going to be neither. Looking at example F, first we're going to start with doing our ratio of y over x. And when I do that, I get 30 over 5, which is 6. Then I get 48 over 8, which is also 6. And I get 72 over 12, which is also 6. In this case, I see that we have a direct variation, and therefore we don't need to go any further with relationship to checking if it's an inverse variation or indirect variation because we know it is direct. Your job now is to go ahead and try these 3 U-Try problems and bring your questions with you to class tomorrow, as well as remember to write your summary.